Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. Today we will continue chapter 3 part 2, and this topic is about first and second law of thermodynamics. So in our previous lecture, we cover 3.1 up until 3.2, but for this chapter, we will cover 3.3 up until 3.8. The objective of this chapter is to introduce the second law of thermodynamics, to introduce entropy, to develop isentropic efficiency for SFEE devices, and to solve problem for isentropic efficiency for SFEE devices. So what is second law of thermodynamics? From our previous lecture, we already know that first law of thermodynamics is about the conservation of energy, which energy cannot be created or destroyed. It can only change in forms. But how about second law? Okay, for second law, it says that the process that involve the transfer or conversion of heat energy are irreversible. Okay, for example, this is a hot coffee in a cooler room, and after some time, it will getting cold. And this is satisfy the first law of thermodynamics. What happen if I reverse the process? Okay, we know that the coffee will getting hotter in cooler room as a result of heat transfer from room air to the hot coffee. And we know that this process will never take place, but it still obey the first law of thermodynamics. And for the second examples, this is a resistor, and we heating the room by passage of electric current through this resistor, and the amount of electric energy supplied to the resistor is equivalent to amount of energy transferred to the room as a heat. How about if we reverse the process? There will be no surprise that transferring some heat to the wire doesn't cause an equivalent amount of electric energy to be generated in wires, but it still obey the first law of thermodynamics. And for the third examples, okay, the pedal wheel mechanisms that operate by the falling of the mass, and pedal will rotate as a mass fall, and it steers the fluid in this container. Potential energy of the mass decrease, but internal energy of fluid increase. What happens if we reverse the process? Okay, by raising the mass by transferring heat from the fluid to the pedal doesn't occur, but it still obeys the first law of thermodynamics. So from this example, it is clear that the process is in certain direction, not in the reverse direction. So the process must follow in one way. Okay, and from these examples, we know that first law has no restriction on the direction of process, but satisfy the first law of thermodynamics doesn't ensure that the process can actually occurs. This inequivalency of first law to identify whether the process can take place or not is remedied by introduction to another general principle, that is second law of thermodynamics. The use of second law of thermodynamics is to identify the direction of the process, to assert the energy has quality as well as quantity, and to determine the best theoretical performance of cycles, engine, and other devices. That's all for second law of thermodynamics.